Trust Service, SSI, VC. Self-sovereign identity, SSI, is an approach to digital identity. It provides solutions to the trust problems in an interaction, namely, how do you know that a claim is valid, and how do you know if a proof of a claim was not faked? Self-sovereign identity, or SSI, enables anyone to prove their identity without the need of a third party. So-called issuers can sign a proof of the claims. Others, verifiers, can verify these claims by using cryptographic functions. The verifier can decide if they trust the claims, and different issuers can sign a claim so that different verifiers can choose which issuer they trust the most. Gradually, this creates an ecosystem of identity and trust without a central point of authority or failure. A key challenge of self-sovereign identity, SSI, is identifying people, organizations, and devices without a centralized system. This would introduce a single point of failure and bottleneck for such a system. A basic structure called the trust triangle provides a framework to establish a decentralized identity system. This identity system is considered to be self-sovereign if the user controls their data. This contrasts with traditional identity systems like social media accounts, where a third party holds all the information about the user. The trust triangle consists of 3 different roles. Issuer issues identity data or credentials to holders. Holder holds, manages, and shares identity data, credentials. Verifier verifies identity data, credentials, of the holder. Core concepts. SSI is achieved through a combination of different concepts and technologies. At its core, it uses cryptographic methods that allow anyone to issue, hold, and verify claims. Here is an example. Imagine you want to watch an R-rated movie in the cinema. You buy your ticket and want to enter the cinema. You are asked to hand them the ticket and show your identity card to prove that you are 18. It demonstrates that you are 18, but it also reveals way more information than they need to know. They invalidate the movie ticket by ripping it apart and returning it to you. You can enter the cinema now. If you leave the cinema, you might not be allowed to enter it again as your ticket is invalidated. Now let's look at the same scenario using SSI and DLT. Instead of an identity card, you would have an app that manages your identity. An official institution would issue a digital identity card containing information about yourself, for example, your name, address, and age. The cinema trusts this official institution, the issuer, and would ask if you are 18. Using SSI, you could prove that you are 18 without revealing any further information. They, the verifier, could scan a simple QR code that provides proof that you are 18 or older and that proves that an official institution has signed this claim and that it is still valid. DLT could now be used to represent the cinema ticket as a token. It contains information about the movie you want to watch, and it is cryptographically connected to your identity. When you enter the cinema, you send them the cinema token, and it automatically checks if all requirements are met. For example, the film has not started yet or is still running. When you leave the cinema and want to enter again, you only need to prove your identity as your cinema token was already redeemed and logged. Applied to the Gaia-X context, this illustrates how participants could use SSI to identify themselves and use tokens to access service offerings based on explicitly defined requirements. Users who want to offer services can decide if they trust certain issuers and offer access tokens that clearly define how, when, and by whom the service can be accessed. Fully automated. All the necessary information can be provided in the self-descriptions of the services and in the corresponding terms and conditions. Users that want to consume a service can now visit a web interface that shows all consumable services by a selected provider, or even filter depending on the required attributes of potential consumers. Once the desired service offering is located, the user can buy an access token for the corresponding service. This access token can now be redeemed to consume the service. The system can automatically facilitate all necessary checks to ensure that requirements are met without the need for additional manual approval. This allows the efficient scaling of business cases in a so-called trustless environment, as trust is replaced by compliance through automation. Compliance by automation is one of the core concepts of Gaia-X. You can see how such an identity system can improve privacy, efficiency, and security. These claims, or better said, identity data, for instance, name, age, affiliation, etc., are represented using verifiable credentials and verifiable presentations. A complete SSI ecosystem can be implemented, paired with other concepts like registries, DIDs, and data exchange protocols. VCs and VPs. Verifiable credentials and verifiable presentations contain identity data of entities such as individuals and organizations. Consider them as digital equivalents of identity documents like ID cards and passports. VCs are created and signed by issuers and contain specific information like the recipient's identity attributes, issuer's and holder DID, and the issuer's signature as proof. VPs are signed by holders. They contain identity information from one or multiple VCs and are created to present them to another party, the verifiers. So, VPs are the format used to share the context described by VCs. Identity and trust in Gaia-X. Gaia-X self-descriptions express characteristics of service offerings, resources, and participants tied to their respective identifiers. Providers are responsible for the creation of their service and participants' self-descriptions. These SDs may contain credentials and claims issued and signed by trusted third parties or by the participants themselves. These credentials include claims about the providers themselves, resources used in the composition of services, and composed service offerings. This is a powerful mechanism that gives SDs certain traits that can allow for discovery and composition of service offerings in a catalog, tool-assisted evaluation, selection, integration, and orchestration of service instances comprising a multitude of resources and service offerings of other providers, enforcement, continuous validation, and trust monitoring together with usage policies, negotiation of contractual terms concerning service offerings and participants. A self-description contains the identifier of the asset, resource, or participant, metadata, and one or more credentials. A credential includes one or more claims comprised of subjects, properties, and values. Each credential needs to have at least one cryptographic signature by the original issuer of the self-description. Additional trusted parties can confirm and thus support the contained claims. This can be implemented using VPs and VCs. This also allows extending the schema to fit the needs of specific ecosystems and data spaces to match their respective domain requirements. Identity and trust. Gaia-X is specified as an open system based on self-sovereign identities, SSI. It requires decentralized unique identities to identify all offered participants and services. Gaia-X hereby uses existing identities and does not maintain them directly. An identity consists of a unique identifier and an attribute or set of attributes that uniquely describe an entity. The issuer will assign a secure identifier for an identity in a cryptographically secure manner. A secure digital identity is a unique identity with additional data for robustly trustworthy authentication of the entity. This implies that Gaia-X participants can self-issue identifiers for such entities. It is solely the responsibility of a participant to determine the conditions under which the identifier will be issued. Identifiers shall be derived from the native identifiers of an identity system without any separate attribute needed. Trust. Confidence in the identity and capabilities of a participant, service offering, or resource used for composition is established by cryptographically verifying identities using the federated trust model of Gaia-X. Using an SSI technology stack allows for participants to trust each other. This basic trust component is further strengthened by a Gaia-X compulsory compliance scheme called the Gaia-X labels. Labels are issued for service offerings only and are the result of the combination of several self-description compliant attributes that individually would be insufficient to support business or regulatory decisions. Lifecycle management completes the system and covers identity onboarding, maintaining, and offboarding. Trust framework. Gaia-X defines a trust framework on established standards and EU regulation. Once the trust framework model is in place, the Gaia-X participants can vote and elect their own trust anchors following the rules put in place by the association. Gaia-X AISBL only serves as initial trust anchor and federator and starts a process towards an elected list of trusted organizations, the Gaia-X registry, to carry out tasks like onboarding, certifications, etc. Gaia-X participants can choose other trust-providing organizations to increase trust level and quality further, depending on their individual requirements. Self-descriptions are crucial in establishing trust within Gaia-X. They contain trust-related information and non-trust-related information. The trust-related part is vetted according to Gaia-X policy and electronically signed by a trusted organization. Changes of trust-related information must be approved. Non-trust-related information can be updated anytime by the holder of the data. The Gaia-X IAM framework supports the federated identity approach and the decentralized identity approach. The federated identity approach uses a centralized identity system utilizing the Gaia-X internal access management component, Gaia-X IAM. The decentralized identity uses self-sovereign identity, SSI, based on decentralized identifiers, DID. Verified credentials can be used to grant access to requested resources, authorization.